everyone. Today we are going to understand chapter number 1, number system of class 9th. See, number system includes various numbers. For example, the natural numbers. Natural numbers means the counting numbers only, which starts from 1 and goes till infinity. Since the counting numbers are endless, similarly, the natural numbers are also endless, goes till infinity, and it is represented by the alphabet N. If you are putting 0 before natural numbers, means the number starts from 0, 1, 2, 3 and goes till infinity. They are called whole numbers. That is represented by the alphabet W. Now you are putting the negative numbers also before the whole numbers. For example, you are writing -1, -2, -3 also with the whole numbers. That collection of whole numbers and the negative counting numbers are called integers, and that integers are represented by the alphabet Z. Z comes from the German word zählen, which means to count. Now, rational numbers, the numbers you already know, which we are represented in the form of P by Q, means numerator upon denominator you were writing in fractions, 3 by 5, 7 by 5. Now, if we are writing -3 by 5, so that is the numbers represented in the P by Q form, where P and Q are integers. That is why we are able to write here -3 by 5. So that P and Q are the integers because integers involve negative numbers also. And remember that Q should not be equal to 0. If Q would be 0, your number will become not defined. 7 by 0 is not a rational number. It becomes not defined because you cannot divide any number by 0. So what do you mean by rational numbers? The numbers which are represented in the form of P by Q, where P and Q are integers and Q should not be equal to 0. For example, you can write -5 by 7, -9 by 5, 0 by 1 also. See, 0 is also a rational number. You can write 0 by 1. All the natural numbers are the rational numbers. All the whole numbers are the rational number. All the integers are the rational numbers. Because you can put 1 in each and every denominator. So, if somebody is asking you whether integers are the rational numbers, yes, all the integers can be written in the form of P by Q by putting 1 in the denominator. But all the rational numbers are not integers, are not whole number, are not natural numbers. For example, 7 by 5, 3 by 5, both are the rational number, but they are not the natural number or whole number or integers. Now coming to irrational numbers. Irrational numbers are the numbers which cannot be written in the form of P by Q, which we cannot represent in the form of P by Q. For example, all the root numbers, root 2, root 3, don't take root 4, because root 4 means 2 only, and that is a rational number. That is a natural number. That is a whole number. That is integer. So, root 2, root 3, root 5, or I have written here one number 1.01, 001, 0001, dot, means it is endless. That you are going to understand in the next slide. So, these are called the irrational numbers. Now, real numbers. You can say that collection of all the rational number and the irrational numbers are called real numbers, which is represented by the alphabet R. Rational number you can represent by Q, irrational number by Q dash, and real number by alphabet R. In this slide, you can see that real numbers includes all the rational number and irrational number. Rational number includes all the integers. Integers include all the whole numbers, and whole numbers include all the natural numbers. With the help of Venn diagram, you will be able to understand and you will be able to give the answer of true and false. When somebody is asking you whether all the natural numbers are the whole numbers, yes, you can see in the Venn diagram that whole number includes all the natural numbers. If somebody is asking you whether integers are rational numbers, yes, because rational number includes all the integers. Now coming to the decimal expansion, with the help of decimal expansion also you are able to give the definition, you are able to explain the rational number and the irrational numbers. See, decimal expansions, whenever you are dividing two numbers, you are getting following cases. In some questions you are getting the division is terminating, means the remainder is becoming 0. Terminating means the remainder is coming to 0. But in some cases you are observing that the remainder is not coming 0. In that case, when it is non-terminating, the remainder is not becoming 0. In that case also you are getting few cases that non-terminating recurring, means the remainder is not coming 0 but the remainder is repeating, and in that case the decimal place is also repeating. And another case is non-terminating, non-repeating, means the remainder is not becoming 0 as well as the remainder is not repeating also. For example, you can see the slide that when we are dividing 10 by 3, you can see here 3 3s are 9, 10 minus 9 is 1, then place point there and then putting 0, then again it's 3 3s are 9, again 1 is repeating, then again 3 3s are 9. So you can see here the remainder 1 is repeating again and again. And in the same manner you can see that 3 is repeating after decimal. So the answer of 10 by 3 is 3.333, and then that also with dot 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 means it is not ending. It is not ending. So you can write here 3.3 bar. The number which is repeating, we can place bar on it. So 3.3 bar you can write it. Now in another question, 7 by 8. 7 you can write as 7.0. Now take that point outside. It becomes 70. 8 is the 64. Then subtract it. You will get 6. And then again 0. 8 7 is the 56. Then 60 minus 56 is 4. Then put 0. And then 8 5s are 40. Now you can see here that the remainder is terminating. In first case, remainder is repeating. But in second case, you can see the remainder is 0 now. So it is terminating. The second case is terminating. The first was non-terminating but repeating. In the third question also 1 divided by 7. When you have divided 7 1s are 7, then 3 remainder, 7 4s are 28, 2 remainder, 7 2s are 14, then 6 remainder, 7 8s are 56, 4 remainder, 7 5s are 35, 5 remainder, 7 7s are 49. You can see that in here again 1 is coming now. So when 1 will come, you will start repeating, the number will start repeating. So it would become 0.142857 bar, because 1 is there means again your decimal 142857 will repeat. So it is again non-terminating but repeating. So in the numbers where you are getting either terminating or non-terminating or non-terminating but repeating, they all are the rational numbers. We will see that how we will be able to convert the numbers which are non-terminating but repeating into the rational numbers. We will learn in the next videos. But here in the second question, 7 by 8, you can see it is terminating. So the numbers which are terminating and non-terminating but repeating are called as rational numbers. But you can see in this slide that we have divided 22 by 7. So 22 by 7, 7 3s are 21, 1 is remainder, point, you have putting 1 point and then 0, 7 1s are 7, 3 0 again. So you will see that again 1 is repeating. So when 1 will start repeat, though 142857 will repeat. So again 22 by 7, you can write here 3.142857 bar. So you will write here that 22 by 7 is a rational number. But you will be having a doubt here because we are saying pi is irrational. You are saying that 22 by 7 is the value of pi. So why I am saying that 22 by 7 is a rational number? Because while dividing we have seen that 142857 is repeating. So by the rule it is non-terminating but repeating. Now we are finding the value of pi, circumference of a circle by diameter. So the value of pi comes to approximately 3.14159265358. And then you can see here it is not ending. and you can see that the numbers are not repeating also. So pi is irrational because it is non-terminating and non-repeating. Okay. And how we are taking the value of pi 22/7? So that the pi value is 3.14. So we are taking the value till 2 decimal places. And above also 22/7 you can see it is 3.14. So that's why approximately we are taking that value of pi is 3.14. Pi is irrational, whereas 22/7 is a rational number. So in the last slide, you can define that a number whose decimal expansion is either terminating or non-terminating recurring. Recurring means repeating. A number whose decimal expansion is either terminating or non-terminating recurring is a rational number. Similarly, you can define a number whose decimal expansion is non-terminating, non-recurring means non-repeating is irrational number. Now we are coming to the operation here. Whenever you are adding rational with irrational, it becomes irrational number. Whenever you are subtracting rational with irrational, it becomes irrational. Whenever you are multiplying rational with irrational, it becomes irrational, provided that p should not be equal to 0. Because if p is equal to 0, then it will become 0 into something is 0 only, and 0 is a rational number. So if you are saying that pq, then one is a rational number, another is a rational number, and you are finding the product of them, then it is irrational provided that p is not equal to 0. Similarly, p by q, when one is rational number and q is a rational number, and while we are dividing, then it becomes irrational number. Again, condition is p should not be equal to 0, because 0 divided by something will become 0 and it would be rational number. So I hope this is clear to you everyone.